but
Yeah, the
I'm
same.
not sure if it could be free, but maybe we could try that. Try it out one day.
Yeah, yeah. Or what we need to do is, we need to connect again. Then it'll give us another 30 minutes or so.
Okay, yeah, that's all right. I don't mind that.
Yeah. Okay. So anyway, guys, so this we said with 3 equal, we check whether these two are the same. I mean, in same meaning. I mean, are they pointing to the same reference of the object? Are they pointing to the same object? So now we have created a singleton. Before we had 2 different lists created. So that's why they were pointed to 2 different list objects. But now what we have is a singleton, right? It's pointing to this singleton.
Yeah.
It's always going to be the same object, we said, right? Because a singleton always give you the same instance of it, right?
Yeah.
It's going to be the same instance of this singleton, isn't it? So these are actually going to be now the same. Yeah, if you run it, we had it false before because of 2 different lists. Now we are pointing to the same. There you go. Yeah. Understood it, Bavitra?
Yes, I know.
Okay, so singleton means you will always have the same instance everywhere. Yeah, so we have just created a singleton in Kotlin with this object keyword. Yeah, so this is unnecessary because you now need to implement all these methods if you want to say a list is going to be empty by telling this size is true, return true. If it's empty and all that, you need to implement it by yourself. For that, something called, which is already implemented for us in Kotlin, empty list.
Yeah.
Yeah, we're done. So we don't need our singleton. Yeah, done. So now is it going to be the same? Let's have a look, what this points to. This points to another thing, which is an object, like we have just created. See, it's serializable. It's thread safe. What does that mean? It's serialized. So these are the things, which the Kotlin singleton objects gives us. So this is now pointing to the same object. Through Kotlin, we are accessing a singleton. So is it going to be now the same or not?
Yeah, that is the same.
Yeah. Same. Done. Right. Brilliant. Okay, so that's singleton for you guys. Any questions?
Yeah, that was nice demonstration with the singleton you made on your own, and then you demonstrated with the I kind of understand it now.
Yeah. See, now nobody can mess with you with singletons in interviews, right? You can teach them when people ask you about singleton. You can go a bit more deeper and ask them back questions. What is a singleton class for empty lists in Kotlin? You can ask it back. There are Kotlin objects. I mean, are singleton already? What are they? There you go. When you interview somebody, you can ask this question. Empty list is a singleton as you have just seen. And what is this? It's referential equality. It's checking the reference of this object, whether they are pointing to the same in memory or not. Yeah.
What was it in Theroux? What was it in Java when you wanted to check for a reference?
Yeah, two equals. And to check the content is 1. But Kotlin, they want to keep the equal for operations, for mathematical operations,
Okay,
right. Yeah, that's reserved. So they put 2 for content checking and 3 for reference checking.
Okay, nice one.
Yeah, that's a good question. Yeah. And things like that, right? Okay. Right. Right. Shall we move on to the next one? If we don't have any more questions, but I'll send you an exercise later.
Okay.
Yeah, to practice a bit more here by yourself, because I just shown you. But this is the way of using a singleton pattern, right? So okay, so can somebody tell me why do you need the singleton pattern?
Why?
Where would you use it? Yeah, Jason, can you try?
I would just go off when you're trying to retrieve data from the internet.
Yeah, and that data is going to come from one source of truth, right? It's always going to come from that place, which is that object. It will not immutate, so which will not mutate. Yeah, it is the same object. That's why it's singleton, right? Yeah, that's a very good answer. And how do you create a singleton in Kotlin?
With the object keyword.
Yeah, brilliant. I'm hiring you now. When can you start? That's it, man. That's how it goes, you know? Yeah. Anyway, so Pavitra, Charit, I know Charit has been using this for a lot of times. Yeah. Is Charit here? Yeah.
Oh, we didn't reconnect, maybe.
Oh. Am I not sharing?
Yeah, I can see your screen. I'm in the room. Pavlitra is in the room. I think Jared is not connected back again.
Charit, yeah. Oh, why is it not showing me that it's sharing the screen? You can see my screen, right, Pavitra?
Yeah, we can see your screen.
Okay.
Yeah, it's in IntelliJ,
right.
and yeah.
Yeah, cool. And then, okay, so where's Charit then? Charit is there, but he's muted.
I'm here.
Charit is there. Yeah. He stays quiet, but you know, I mean, he knows a lot of things, you know. I know. Yeah. He's an all-rounder. All right, so if you're happy with this, shall we move on to the next one? Next design pattern.
Yeah, sure.
Guys want a break or?
No, I'm all right.
Okay, cool. Right, so what is the next one for the creational pattern? Yeah. So we said, you know, these are creational. So singleton is all about creating objects, even though it's going to create just one instance always. Yeah. So it's a way of creating. So if you always want to create one instance in your program, in your application, when you're building something, you choose the singleton pattern. Yeah. Right. That's it. And the next one is, let's see. Yeah, factory.
Factory. Okay.
Yeah. Has anyone heard of this? Factory method.
Yeah, I don't know if it's the same thing, but when I was doing the training through Google, there was something to do with like a factory method, with the view models or something. I don't know.
Yeah. That's why it is called factory. So what is a factory normally? How will you describe a factory?
This manufacture products.
Exactly. Manufacturing of products, right? A lot of products. Yeah. Somewhere we create a lot of things. Yeah. So if you want to buy a car, we need to go to a car manufacturer, you know. That's where he will have the factory and it will create lots of cars. You know, that's the factories for, you know, like in real life. So if you want to create some objects in programming as well, we will have these factory methods, you know. So we will call these factory methods and say, hey, look, create these objects for me so that I can use them in my program. Simple as that, right? So that's why we have this factory method. So instead of having if you don't have a factory method, then our program can become a bit messy, you know, because people can create objects everywhere. Imagine you don't have a car factory and people own, you know, garages to create cars everywhere. Where do you go and buy the cars? Well, that will be a big problem, right? Same here. We don't want anyone to create objects throughout the whole application everywhere. We want to group it in a place that, I mean, we can create those objects from one method, calling one method. So I know which factory method to call always to create these objects. Yeah, that's it. That's the explanation for a factory method as the factory stands for. Sorry, as the factory stands for. Yeah. Yeah. Okay. Yeah. Understood it, Jason?
Yeah. It's a little bit foggy at the moment, but I do understand the concept of factory is where creates objects for you.
Yeah, exactly. That's all it is. You know, that's all it is. So yeah, if you put that into practice in your you know, projects when you're working on a project, if you don't have a factory method and you're creating objects, same kind of objects, then you will get into problems, you know. Yeah, I'll show you how it will be a problem with an example in a bit. That's why we would like to have a factory method. So if you reviewing somebody's code and you see similar objects are created in 2 different or 3 different places, that's an immediate failure of the code review. You can stop it there and you can say, look, mate, why don't we have a factory method and create these objects in this place so that anyone can call this factory method to get these objects. Yeah, we'll see an example, right? Okay, so Singleton, we have just seen. Let's create the factory. Factory method, right? Okay. I don't need a class. See, this is the other thing of Kotlin, right? See, in Java, you would need to create classes to do something. But here, I can just create files, and I can just write my functions I want. That's why it is a functional programming language as well. Yeah. So in Java, you need to create all the time the classes for no need, I just only need a file, which is called this, isn't it? Boom, I'm done. And I can create my functions.
Right.
Because the functions are the first class citizens in Kotlin. Every book you read or open, that will be the first sentence about Kotlin. It will say functions are the first class citizens of the language, because that means you can create the functions as you create classes in Java, because eventually they are under the hood will be created as objects.
Right.
Yeah. So creating functions is also a bit of a memory issue. But if you create it in a way that they are created for the purposes, then you're fine. Right. So what are we doing? Oh yeah, main. What is a main function? We studied about this. Pavitra?
Yes, sir.
Yeah, what is the main function? Do you remember? Yeah, why do you need a main function? Remember, this was the first thing we studied at the first class, I think. And Charit was talking about what was it? Python, right? Python, yeah. Python, and where are the entry points and all that. Main function is what is it? See this little arrow here. So I can play this. That means I can start this application through this. If it's a main function, that's your entry point of the application, right? Yeah. Yeah, you are okay. So you will see this because we haven't seen this as an example. This is an example. You see in Kotlin, right? I have just created the main function, and ID itself identifies this as this is where I'm going to start my application. That's why this play button is here. I can just start playing it, run it. Yeah. If it's a normal function, for an example, yeah. If I just create a normal function, right? If I create a normal function, this cannot be started. This cannot start running. See? But if it's a main, that's the main entry point. This is the entry point for the application. But I can call the test function inside it. So now everything's going to start running if I click the play button here. If I start the application to run, that's why it's called the entry point of your application, right? Yeah, that's why I'm keep creating the main functions as I'm creating small applications, So this we have just created a small application just to do this. So I can run this as an app. It's an application, right? Because it has a main point, entry point. Yeah. So you will see when we get to Android and create an app, you will see where everything starts as how an application starts as where that the entry point is, where that main function is when you start your application. Yeah. Think of it as you're creating an Android application, and when I download your application and run your application, where does it start running? Which place of the application your code starts running, or instantiating all your objects inside and everything, and it actually starts running. You will see that in Android application when we run it. Sorry, when we build it, but I'll show you. But this is this is a cheaper way of creating an entry point just to run an application, so that ID will know, okay, this is an app I'm creating, and this is where I'll need to start running. Yeah, because if you have an app, somewhere it needs to start running, right? You know. Yeah, that's why they're called entry points of your applications. That's why you need to have a main function. Yeah, cool. Anyway, just remember that. But Baitra, we will I'll show you you know, where how application starts when we actually start building an application in Android. Yeah. But remember this, whenever you see a main function, that means that's your entry point to your application. So that's where you will start running everything. Yeah. Cool. Right. So now where are we? Oh, factory method, right? Okay. Let's demonstrate how do we see a factory method in an example. Right. For that, okay. What? I was thinking about this, right? Hold on. Online paint or something. No, we've been using this online paint for a while, you know, to draw things on the board. And then I've come across this. This looks pretty nice, whiteboard, you know. So I can,
yeah,
write
cool.
things and draw things and all that, you know. Yeah. But bear with me because I'm also new to this, you know. So
yeah, that's a nice find.
yeah, I was just, because I know, you know, there are tools which you need to pay, which we use at work as well, you know. But then, you know, we're just having fun here, right? So why do we need to spend money? Yeah, you know, if you want, you know, we can purchase one, but you know,
no, man, all the free stuff's the best.
yeah, exactly. That's true. All the free stuff's the best. Yeah, cool. All right, so I was thinking, right? Okay. How many of you have played chess? How many of you know how to play chess?
A little bit. I'm not that good.
Okay, Pavitra, are you an expert?
I don't know.
Chess. Can you play chess?
Not much, Anna.
Okay, Charit?
I know the rules about, but I couldn't play with.
Okay, yeah. Me the same, guys. You know, I mean, I have a very little knowledge about chess, right? But I know it's a very it's a good game for using your mind properly and all that, right? It's a tricky, mind. How do you say it, Jason? Is a mind teaser game, isn't it?
Yeah, it's more like a mind. Yeah, brain teaser.
Brain teaser. Yes, that's the word. Yeah, the brain teaser, like playing a Sudoku game or something like that, right?
Yeah, like
I love
thinking
Sudoku.
9 moves ahead and stuff like that.
Yeah. So let's imagine, right? Because I've seen this, you know, from a book that is a really good example to show the factory method. So that's why I'm picking this as well, you know. So let's say where are the shapes, guys? Where are the shapes? No, where are the shapes? Here. There it is. Oh, lovely. Right. Imagine this is our chessboard, right? And now, lines. So no. I want the line. Maybe not. So I cannot move over the thing. You see what I mean?
Yeah.
You can only move the object is selected. Yeah, that's true.
Okay.
Yeah, that's how all the paint programs work, right? Oh no. Okay, anyway, I just don't waste time. Yeah, so imagine this is our I can draw the line like that. Imagine this is our chessboard, right? It looks something similar, right? Yeah. Yeah, this is our chessboard. It's not entirely a chessboard, but you know, just to give an idea, right? This is our chessboard. And think, you know, oh no, not that. Oh, hold on. Then yeah, let's draw another shape. Yeah. Then think, you know, there are two chess pieces, yeah, in two different places. Yeah. And, let's color this. How do I color this? There it is. Okay. No coloring it. But anyway. Maybe I'll need to color it. Yeah. I don't know. Okay, anyway, just yeah. So we have two different chess pieces on this board, right? This is my chess game, and it's loaded. It's people are playing. They're moving. They're moving.
There's a brush like icon top right corner.
I hear this one. Which one, Jared?
Top right corner.
Top right. This one?
No, other side. Other side.
I hear you mean.
Yeah.
Ah, there. Ah, yeah, man. Oh, that's clearing the board. That's sort of
Oh, sorry.
That's a duster. That's our duster, man. No, you don't want the duster. Yeah. Okay. Anyway, we don't need to color it. We can see two pieces on the board, right?
Yeah, we understand.
Yeah. So imagine now, I am playing this game. This is our game. This is our application, right? This is the computer application, which is running on a device, not a physical chessboard or anything like that. This is something that we have written, right? Now, I'm going to quit this because I don't have time to play anymore. Yeah. What do I need to do? I need to save this game board, right? Yeah, I'll need to save it. So in a way that I will store the position of these pieces, right? Where they were in a file or something, right? And then, so what do we need to store? If you think of this as a problem, let's brainstorm and see, what do we need to store? So we need to store something, we need to store this, right? So if you think of it, we need to store these two guys, yeah? So there are two pieces, right? So, yeah, so we need to store the type of the piece, yeah? So imagine this is queen. And I can think of this is a king or something, right? So we need to store the type of the chess piece and where its location. So let's say this is 1 and this is A or something. I don't know how we coordinate this, but just say this is 1, A1 or something, yeah. Column A, row 1, yeah. So the same goes to the king, right? So the king piece will be, the type of the piece is king, but the type of the piece here is queen. Yeah, so the type of the piece here is king.
Yeah.
Yeah, and he's at maybe say 8 and M or something. Yeah. So M8, yeah. Right.
Yeah.
So store this. That's how we can let the player come and resumes the game. So when he resumes, we need to now read back from where we have stored it in this way and load the game back. Yeah.
Yeah.
Yeah. Simple as that, right? This is what we need to design as, right. So when we do this, we are going to create the chess pieces back to be put on the board. Yeah. So we need to create these chess pieces. The type of the chess piece is a queen. Yeah. And a king here. So we need to create them back. Yeah. As we store them, when we get it back, see, we are going to create these guys. Queen and king again. Because of they are the pieces here. So can you see the objects we are talking about here? The chess piece. Yeah. The chess piece. So the chess piece will have its type and the position to put back on the board, right? So it will have its position and its type. You see, that's how I will declare or design my object. So I will need to have an object called chess piece with its position as the value and the type being another value. Yeah, this is my object. See how I am starting to create my objects?
Yeah.
Thinking of creating objects, to accommodate this, to store it and to resume. So even when I'm storing it, I would store this. This is what I will store, into some memory file or something. And then when the resumes happen, I will load it back from the file as these objects. So when I'm loading it, this information, so when I'm storing, I can't just store this as an object. I will need to put it into a string form or something, a JSON or something, they are data storing formats, right? So we don't store objects as objects, we just put them into a JSON format or something, so that it'll be all in string. Strings, are less heavy, and it wouldn't take much of our memory, so we can store the strings into a file. So I'll convert this object into a JSON file, which will be all string, as all I need to know is the type of the thing is Q, and the position is A1. So this will be my string. To store it, and then the next one, and blah blah blah. So I will store it as string, and then when I get it back, when I resume, I will need to read the string file and create the objects, right? By reading this information. Agree? So when it gets saved, I will put the information in a string format, and then when I'm reading it back, resuming it back, I will read the string file and see what's the information coming out of that. The type is Q, so that I will create the queen class, and if the type is K, I'll create the type is king class. King object. Like an object will look like that. Okay, let's go and do this in our coding, right? So immediately, what do we need? Can you think of anything?
A class?
Yes, of course. What kind of a class this would be in Kotlin you would choose?
Data class.
That's it, man. Brilliant. I want you to start tomorrow. That's what I'm saying, This is very good, Jason. This is how you need to think, Data class, right? And what that would be? Chess piece, isn't it? Right. No, just the chess piece. But see, if you create a data class, why is it a problem now? Why is it saying, I can just have a data class? The data classes are meant to be storing values, so this class should at least have one value in it. That's why it's going crazy, So the position, right? We can have a position. Position is mint. Now we just created a chess piece, and right, if I now, okay, now we have different guys here, isn't it? The king and the queen. So we need a data class for king as well. So he will have the position. Just bear with me. So queen. But can you see some relation here? And something is not looking correct right now. So we have a data class for check piece, and then individually king and queen. How do you group this? Can you think of anything in Kotlin, class-wise?
A sealed class?
Yes, man. You are rocking, man. I'm telling you. Yes, but if you remember this, see, when you see a hierarchy of objects, we choose the sealed class to put them together, right? Baitra?
Okay.
And Charit, we're happy with that, right? So what this is telling is, this needs to be the sealed class, which would be the actual hierarchy of definition we are having, so we will now then say, okay, that's the check piece, but these are all check pieces as well.
Right.
You know what I mean? And then you pass the position. Why this is that? Because we are building the hierarchy. This is the position, but then
because you got the val keyword or something.
You don't need that, because otherwise we'll have to override it. But then that's the data class, isn't it? All right, okay. Maybe just leave this for now. Don't worry about making this as a val, because I want to keep the val for the data classes itself. So,
that's where I got a little bit tricky. It's a bit fuzzy, that bit.
See, when you put a val in an object, that's what you're saying as, this is going to be a value in your class as well. So, if you extend it, you need to override it, or if you just keep it the construct argument. So if it's not a val, that will just then be a construct argument. So when I'm extending it, I'll just pass it, but I don't need to worry about overriding this and all that, because if it's not going to be a value in the class itself. Yeah. Same all that principles of object orientation, but this is the syntax for it. So if you have a seal class and in Kotlin you can make something val at the same time, construct argument too. You see?
Yeah.
Clear, right? Okay, so we have just created a hierarchy of classes, which are check pieces in this case, chess pieces in this case, and the pieces are king and queen. Yeah, right. So we have a nice hierarchy here. You could have just created an interface as well, but we have choose the seal classes because it will help you later in the program when you use when conditions. I'll show you how that becomes handy as well. Yeah.
Okay.
Yeah. Just sit back and relax and watch. Yeah. Yeah. So, right. So what do we now have? We need a function, right, to create these objects when I'm loading this. And think, this is the file. Imagine that file is given to us, the file we have stored, right? So, notations or something, all the notations are coming from this file. Yeah, list of would be a string, and the queen is at where is it? It doesn't matter, right? A1 or something, isn't it? A1. Yeah. And the other one we have stored the king, which is a type, and he's at M8. Yeah, if I remember that correctly. So now we have said, what position is it? But then what's the other one missing according to this information?
The type.
Yes, exactly that. So type. Yeah, but I will always have the type first because it has more weight than a position, right?
Oh, right.
Like to have a better understanding when somebody reads this, what be a char.
I didn't think it mattered, but yeah, now I know.
No. I mean, it's not going to. It's the same as, I mean, the order doesn't matter here, but as we develop, yeah, we will have that, or we will think of that order anyway, in the back of our mind. The other type is the very first thing we'll worry about if I need to know what that class is, isn't it? And then his position, isn't it? Yeah, even then, that's how we will start checking things, isn't it? If what is this? We don't want to go there without knowing the type and check the positions, and we will always check first the type, if you want to query that, what that thing is, isn't it? Yeah. So yeah, and things like that. And then we'll also have this for that guy. So it's the same. Yeah. And then so now we can say same in the same order. Type is going to be a char value. So we need to pass the type as well here now, right? Yeah, that's it, right? So we have the type as well now, so anytime when we read this information will let us create these classes. Yeah, right. So let's create that function, create pieces. No, so the create pieces should take this information, because imagine, are you with me? Because we're just reading this file and creating the board back. Yeah, that's what's happening. That's what we're doing. Yeah, so which is what is this? This is the list of strings, isn't it?
Yeah, the notions.
Yeah, notions. Yeah, because that's the list. We read it from the memory, which is string, and we're just receiving this. Yeah. So how do we create the classes by reading this information? That's our task now, isn't it? So how would we do it? It's a list, So I can simply call each. I can go over each of them. Yeah. And then each of that is going to be a notation. Yeah, I will just say that. And now I can say when Yeah, I can use the when here, and I can say when notation. When notation is now the type. Now we need to check the types, no? Oh, no, sorry. Before this, we have the notation, which is this. Each of them is going to be the formation of that, right? So we need to now destructure it, so to get the Q, A, and 1 separate out. There's a better way of doing that in Kotlin. That is thou destructuring. So first one is the type I want as, and the position, and position is the whole thing, isn't it? Actually, the position is going to be A1, so let's keep this as a char as well. No, actually string, because that's going to be 2 characters, right? Isn't it? You with me, right?
Yeah.
So right, so yeah, that's my position. So how do I do this? So I take that. No, actually, yeah, that's fine. No, this is the queen, this is the row, this is the column and row are A and 1, isn't it? So position, let's say row. Let's make it even granular. You see what I mean?
Yeah.
But I can put them back according to what the exact location is. So I'm gonna even separate that out. So call row, and then you have the other one, columns in it.
Yeah. Right.
Let's break it down as it looks, isn't it?
Yeah, I understand it. Yeah.
Position row, which is the char as well now. Position column, which is the char as well now, right? So I can just pass these guys now. Same goes to here. Yeah, right. Okay, so now I'm getting them back, position row and position column. Yeah, by doing what? So I have the, it has to be inside because this is my for loop. Yeah, I'm iterating over each of these coming in, which is that notation. So equal to notation. So what this does is it will take this string and it will put each of the characters in that string to an array.
Yeah.
So it will become like this: A1.
Okay.
Yeah, Q A
1.
Yeah, so that's the array now. Yeah, and I am destructuring it to values. This is called destructuring in Kotlin. Yeah.
Okay.
You break an object you have into separate things at the very same line. Yeah, if you think of it like that. Yeah. So position row, position column, all of that destructured by separating them into an array. Yeah. And now we have them, right? So how are we going to check this? So now if what? If yeah, when the so now we can check the types, isn't it?
Yeah.
Sorry. Type, so Q is the character. If it's that, I'm going to